So one thing that we're going to take a look at is how to build an HTML5 application that employs Ajax and a web view under the Android mobile phone that utilizes local file resources. Remember that in our project folder under Eclipse, there's been this folder called Assets, and we haven't needed it yet, but we're going to employ it now in order to take a look at an example HTML5 application where we can actually load all the HTML documents into the app, into the phone, and not require internet access. So we can blend an Ajax application that has perhaps half the user interface components locally, and the other half it can grab them dynamically when it needs them off the web. So the way that we reference the assets folder of our project is not actually by using the exact spelling of the folder in the project. There's another spelling for the project called Android_asset, and this is the pathway to the folder in our project called assets plural. And we'll take a look at sample code and explain why that is. Also, when we build the main.xml user interface, we're going to bring in a reference to this tag, this Android markup language tag called a web view. And programmatically under JavaScript, we're going to set some of its properties like set JavaScript enabled to true. And then we'll take a look at how we can load HTML documents from a local file. So we'll say something like this. We'll invoke this method called load URL, passing in the protocol file colon in place of, for example, HTTP colon. But we set up the 3 slashes, which mean that the file is on the local hard drive or in the local file system of the phone. Now, another interesting feature of using a web view within an Android application is that the buttons on the Android form can trigger JavaScript functions on the web page. So we can directly interact with the HTML and the JavaScript inside of the web view. And the way that we can do this is by passing in a JavaScript reference, load URL JavaScript colon, rather than using HTTP colon or file colon. If we just say JavaScript colon, what that means is that we want to execute JavaScript within the context of the browser window. And we can call functions that are written in JavaScript from our Android Java code. So this is how we can interact between the mobile phone and the internet, the web, and also local HTML documents. So we're looking at the Eclipse developer environment for Java. We've already loaded all the Android stuff here, so we can build new projects that utilize the Android APIs. So we're going to create a new project. So File, New, Project. In the project type, we're going to use the Android project template. And here we're going to set up the project name. So using the naming convention that we've already used before, AppDev, Android, and then the name of this project, WebView. And we'll put the type of thing, the object type project, on the end of this name so that we know what it is when it pops up other places. So the platform that we're targeting, we can target the level 12 Honeycomb 3.1, or we could go back in time and support a basic platform. And since the features that we require were delivered way back in level 4, this example we can run under level 4 and that'll work just fine. So the application name here, AppDev Android WebView, and then we'll flip this from project to application. So now when we get into the questions under properties here, we're talking about things that relate only to the mobile phone itself, not the Windows desktop or Eclipse. So the name here, remember, is just the Eclipse name for the project, but everything that we do down here actually impacts the application's arrival into the Android market. So this is the name that we would see in the Android market. We want to set up also a package name. So this is the folder name on the mobile phone. And remember that because the mobile phone might have apps from different vendors, it's important to keep this unique. And by flipping our website address upside down, we guarantee a unique name, a unique address. So com.appdev, and then we'll borrow this. And we'll change the name on the end of the type. We'll say package. Under activity, we'll tack that on the end here. And the Min SDK version of 4. So we could skip the next step, jump right to finish. We'll open up the Project Explorer. We'll collapse the previous project. We'll focus on this new project. And just like before, let's take a look at all the files the template created, and let's run it before we add anything significant to it. So we have the activity.java file, that's our form, the user interface. The generated file is empty because Eclipse hasn't had a need yet to put anything in there. The assets folder is empty, and that's the one folder that up until this point we've looked at it but not utilized it. And in this example we're going to employ that folder, and we'll find out why in just a minute. So the resources folder is everything that has to do with the markup and things that are not part of the Java proper environment. It's basically assets that we're going to bring over into our project that the Gen section is going to link to Java for us. So under values we see strings XML, and we have the default hello message and the app name. So the app name is important, but the hello is optional, and we're going to change this to 3 asterisk. And under the layout we'll look at main. This is the user interface, and under the activity Java this is the template for our code. So what we want to do is to run the app, make sure everything works, and little things like this, the R reference is undefined. And that's fine because basically this is really interesting. So the template creates the project, but it doesn't compile and build it yet. So if we were to say clean the project, hit OK, and then build it, notice that the Gen folder now contains stuff that it didn't have before, and we really haven't written any code. We've just added a couple asterisks to the strings, but it generates all this stuff. And if we look at the string node, we can see that hello is now defined, and that's the reference to the code that we see under the Java activity. If we go back into this Java file, so that red little thing is gone because the definition of r.layout.main, which is an integer, is now defined because the build environment of Eclipse generated that. Okay, so we're almost ready to run this in the emulator. Let's go over to the run configurations first, and for each project we set up one of these. So we want another Android run configuration, so we'll say new. So basically, because Eclipse is very generic, it's very abstract, we could build enterprise applications, Java applets, we can also build mobile phone applications. We need to help explain to Eclipse what it is that we intend to do with this code, and we intend to send it to a mobile phone. So we'll say appdev Android WebView run configuration. So what this means is that when we launch this project called WebView, we would like to do something with it. We'd like to launch an emulator manually, which means we want to pop up a dialog that asks us every time. Okay, so let's test that out. We've got the level 4 running, and we also have a level 12 running. So that's perfect. Our 3 asterisks are here. Everything worked. We have no build errors. So now we're ready to build the additional components that customize this application. Remember that our goal here is to set up the user interface to employ a web view. Now, when I look at this screen, I notice that it's in portrait mode, and portrait mode is often useful for music and playlists, but it's often not useful for navigating across the internet or even interacting with database applications or enterprise applications. So let's say, for example, that we want to really build an interior application that uses Microsoft SQL Server on the back end. And let's say that we want to use an Android mobile phone for the front end, and everything in the middle is up in the air. We don't know yet exactly how we're going to make that happen. Well, basically we'd probably want to use landscape mode to build that application. And one way that we can achieve that goal is by employing a file. There's another, in addition to the interesting definition of this assets folder, there's also a hidden folder that we can also add called layout-land for landscape that allows us to customize the UI for both portrait and landscape mode and make them separate UIs. The basic concept there is that we have to have the same number of objects, that the object names have to be the same. They just have to be in different places to match the user interface. So that's something to keep in mind. So let's just focus on one user interface at this point, and we can always come back and add a second one that customizes it. But just keep that in the back of your mind that you could use both portrait and landscape in two separate XML files. So what we're wanting to do is to take a look at how to build an app that has a web view, that has a button, that interacts both from the HTML side and from the Java side. So let's start with the stuff that we know about. We know about buttons so far, so let's bring in a button. So here's the button. It's on the Java side. It's not within the HTML. We're going to add an HTML5 document in just a moment, but we're not there yet. So we have this text view. We have attributes sitting on their own line. Everything here looks pretty good. The background color, we can change that. So solid color, white. The opacity is the first two digits, then the RGB values. So let's stop here and see what this looks like. It's better to test the app about every minute or so and find the bugs fast, because if bugs cascade, it gets really complicated to track that down. Okay, here we go. So here's the button. And at this point, we can see the UI react to the click, but we don't really see any response here. And also, we don't see necessarily any kind of response in the user interface. So let's clear the log, and let's add entries here to the button click, just to make sure that all things are good with the button. So two things have to happen. First of all, on the button's name, we need a good ID for that. The text right here, we'll come back and change it in just a moment after it's obvious what its purpose is, but the intention of this button when we're all finished is to click on this button and have it actually talk to the web page in HTML5, have it invoke a JavaScript function in Ajax that does something using dynamic HTML. So we'll leave the button text right now as just simply button. And let's give this a better name. So remember that throughout the examples we've been tacking on XML to all the object names that reside in the markup language, and we've also been tacking Java inside of all the mirrored pointers that are on the Java side, just so that we know that every time we see this B1 for the button, that it correlates to the same object. There's just different handles to it. Do we want the handle to the same mirrored object? Do we want the handle from the markup side, or do we want the handle from the Java side? And this helps straighten up in the categories in our mind how we're referencing this one object, which is a button. So on the width, let's set this to fill parent. And over on the Java code side, so if I was building a VB.NET application, I could think of this as the code behind. Even under ASP.NET, it's the same concept. So under ASP.NET, we have the HTML side and we have the code behind. The mobile phone environment for Android is almost the same as ASP.NET in that there is, instead of C# in the background, it's Java, and instead of HTML in the foreground, it's Android markup language, but that's the basic concept. There's like a parallel universe. They're almost applying the same paradigms. So let's try this out. We're going to send a log file entry on create function name, and then the message begin. So begin, end, definition of the log file undefined, so let's bring that in. And that's good. Now what we want to do is to have an on-click event that handles the button click, and there are a couple of different ways that we can do this. If we were running under Honeycomb, there's a simple way that we can add an attribute under the markup language that just says on-click equals function name. But we're not going to go down that easy path because in 2 lines of code in Java, we can make it work on all the way back to the level 4 version of the Android phone. So for backward compatibility, we're going to do this option. We're going to grab a handle to the button, and we'll call it B1 underscore Java. So this right here now, we're intending to have it point to the same object that this does, and that's this button object right here. We're just using a different name to reference it. And remember that the purpose of the r.java file, here's the text button 1, which is outdated. It needs to be synchronized with the code because we've already renamed it to this. So to resynchronize this before we actually compile it, one thing that we could do is to go to the project menu under Eclipse and ask it to clean up all the stuff that it can, and then to rebuild our project. And now we'll double check the gen r.java file. And that's the current version that's resynchronized with our source code. So this is the user interface. We have this object B1 XML. And we'll invoke the magic function this dot find view by ID r dot ID dot button B1 XML. So now we get a yellow squiggly. It basically says that this is a space in memory that we're allocating but never using. So do we want to use it or recycle it? So we want to use it. And what we want to do is to set the on-click listener to point to this class. So this is the class right here. Currently it's based on the activity class. What we could do is say it implements the on-click listener. So what is the definition of an on-click listener? We could bring that in. I'm just, by the way, hovering my mouse over the red squiggly. I'm not pushing any buttons. I'm just waiting. And now what happens is that we're saying that this class implements on-click listener, which makes this happy because this is expecting to pass in an object that knows about the on-click listener interface. But now the class itself is unhappy because the expectation is that it already implements methods to implement that interface which don't exist. So in order to implement the functions, in this case it's just one, but sometimes it's 4 functions or 400 functions, but in this case it's just one function called onClick, so I clicked on that. And there's one parameter that comes in, V for view, so let's just change that to just capital V1 so we know that's something that we modified. And here we could do the same thing. We could do the little log entries at the beginning and ending of the function just for debugging purposes, make sure all is well here. And let's rename this to onClick. So we'll hit save and let's test this out. We can watch the log file. It's empty at this point. That's good. We'll launch on the 554 emulator. So this is the dialog right now under the logcat. This is the dialog between the Eclipse developer environment and the phone itself. So the onCreate function, begin end, that all looks good. Now let's test the user interface. Here's that big button. If we click on it, this is good, begin end of the onClick event for the button. So now we're good to go with adding some code specific to the web view. The purpose of the button in this example is to invoke a JavaScript function that lives in the HTML5 document, and to make the point that we could build mobile applications where the Android code and the Ajax code work hand in hand to build an HTML5 application that fortunately can run on any phone. If we concentrate 90% of the effort inside of HTML5, we can actually deploy it to BlackBerry, iPhone, Windows Phone, Android phone, and just fix up the 10% wrapper for that platform. Okay, so let's go back now to the project. Here's our project, Android WebView project. Here's the references to r.java that are bridging things like the button from the user interface. So let's go back into that user interface again. So what we really want to do is to have a reference to a web view. So there are a couple different ways that we could do that. We could type out web view and then populate the properties and the attributes. Or if we forget how to spell that, we could come over to this little tool right here and drag and drop it from our little widget, our little toolbox area here. So in this toolbox here, we have form widgets, we have text fields, and we have layouts and composite. So under composite, we have this bright orange thing, and right below it, we have web view. So we'll bring that into the project, and I prefer to always drop these at the bottom, even though I intend to place this a little bit higher on the screen. If I drop it at the bottom of the screen, I know where to find it inside of the markup language, and then I can push it around and put it where it needs to be. So here's this web view, which is part of the standardized web kit that all browsers are now using, including Firefox, Safari, and every other browser except for Microsoft. So if we take this value and we place it here in the middle of the screen, and let's go ahead and set up each of the attributes. So here we go. Android.webkit.webview. We'll give this a different name. We'll just call it WV1 underscore XML, because we'll also make a Java mirror of the same object. The width, the height, the fill parent on the height probably is not necessary. And at the end of the day, if it doesn't align properly or the way that we want it to, we can flip over from the linear layout to an abstract, more absolute layout, so we can control the positioning a little bit better. So let's test this out. We have this web view. Let's go ahead and launch it on L4. And that doesn't look bad. It doesn't look good either. So we don't have any content yet for that web view. So what we're going to do is a couple of things. We want to test it first just to see what it looks like before we set the height to fill. Sometimes when we set fill parent on some of the objects, all the objects below it actually get shoved off the bottom of the screen, and so we have to come back and do something different. So now let's take a look at how we can load the content of this web view, and for now we'll hook it up to the button click event. So back under the .java code, let's add something here that references that web view. Importing the definition of a web view. Here's webview.webkit.android. So we're going to mirror the markup language side with the Java version of that same object, and it's a pointer in memory. So we want to say this dot find r.id dot webview1 and webview1 dot load. So there's all kinds of stuff that we could do here. We could load HTML from text. We could load it from a URL. We could load it from a URL off the internet, and we could try something like that first. So now let's take a look at a sample external website. We could say something like this: http www.google.com. And remember that just like we grant permissions to send SMS text messages from another section, we took a look at that, we also need to set permissions to access the external internet. So let's save this file, and let's locate the manifest.xml file, and we'll add a permission. And the permission that we're looking for is Android dot permission dot and then internet all caps. So that should work. Let's save the file. Let's stop where we are. We'll hit run. Click on the button. We'll wait just a moment. And there we go. So basically now we have access to the external website. We can see the Google screen here. And we're accessing, in this example, an HTML document that lives outside of the mobile phone. But we want to focus our effort on what it looks like to load an HTML document that's inside the mobile phone. And when we load the document from inside the mobile phone, we can build an application that actually deploys with the APK file, the package for the mobile app, and also make a lot of things happen without any public access to the internet. Because one of the assumptions that we should make is that the data network is either unavailable or very, very slow until we get back into the office and resync with a Wi-Fi connection. Okay, so now that we know that we can access content on the internet, let's take a look at how we can access content locally. So from the Project Explorer window, we're going to look at the not the Gen folder, not the SRC folder, not the RES folder, but the Assets folder that we haven't really used before. So we've talked about the template for an Android project, a mobile phone project. We talked about how there's an SRC folder, and that contains all the Java stuff that we write. There's a Gen folder, and that contains all of the generated code that we get automatically from Eclipse that help bridge the gap between the markup language and the Java code. The Google APIs, if we're using the open source Android only, we would see this only. But if we're using the Google corporate stuff, we get maps and some other licensed code. The resources folder is all the markup language, but the assets folder is something we haven't employed yet. So let's try this out. We're going to add a new file into the assets folder, and we'll give it a name. Let's call it appdev Android Ajax file. So here's that file, and we could put some basic HTML into it. And we'll save it. And let's go back and look at the folder here. Let's put an extension on the end of this. It doesn't have to have one, but we can add one. We could call it .ajax or .html or something like that. So let's rename, and we'll put .html. Okay, so now there's a little globe, and the Eclipse developer environment thinks that that's a web page. So what we can do is to reference that web page inside of the web view. Now the question is what to do with the object handle to this file that lives under assets. Do we see something under Gen? And if we look under Gen, under r.java, we don't really see anything related to assets. And that's true because we don't reference the content under assets the way we do under resources. We actually have to reference them through the file protocol. So how does that work? If we open up the source file, and let's go ahead and locate the button click event, and let's comment out the reference here to Google and replace it with something different. So we'll say wv1 java.load URL. So this is going to be a little bit different than referencing a website on the public internet, because rather than saying http something, we're going to back up and say file something. Rather than going to the root of a server, we're going to go to the root of the hard drive on the local machine. So next is the file name. We would think by default that the folder assets would match the name of the folder here in the project, but that actually is not true. When the APK file gets compiled based on what we see here, the APK file contains a folder called Android Asset. So that's the actual folder name that gets deployed into the memory of the phone. So now we can say appdev Android ajax.html and load that file from that folder. So appdev Android Ajax, is that the same name exactly? If we find that folder, appdev Android Ajax file, That looks better. So let's test this out. What we're testing is, rather than loading the Google website across the internet, can we load a local file? And the local file says simply hello world. Let's go ahead and find that file, open it back up. So this is what we're expecting to see inside of the phone, hello world. Here's the button. And that's the HTML from Ajax. So we're on the right path to building Ajax applications with HTML5 that live inside the Android mobile phone. And whatever we learn here in this section can be also applied to developing mobile apps on BlackBerry, iPhone, Windows Phone, in addition to the Android phone, because this is all just standard WebView stuff. And all the phones, in fact all the browsers, use the WebKit, just like Firefox uses the WebKit, BlackBerry, iPhone, Android, and even if we run this on a Windows phone, it's still running Internet Explorer, which basically has the same basic identical features for the browser as well. So now let's take a look at some of the other features that we can employ here for the web view. Like, what if we had a button, maybe button number 2, that didn't just load the file here, but maybe it actually called a JavaScript function inside the HTML document, and using Ajax, it updated the content that we see here in place of hello world. All right, so let's go ahead and add another button onto the mobile phone side, the Java side. So in main.xml, let's add button number 2. And we could change the text here to say load HTML5 Ajax file. And then over here we'll say call JavaScript Ajax function. So this is called button 2 XML. It needs to have a mirror over on the Java side. So we can copy and tweak the code that we already have. Control C copy, Control V paste. And we see a reference here to the red squiggly for this thing. But if we clean and build, that's better. So the r.java was just out of sync with the code that we'd written. And by cleaning and building it, it catches itself up. So what to do then for this button? Now, there's an interesting question here as to how the on-click event is going to recognize the difference between these two buttons. So to make this point really, really obvious, let's stop and run the code. And we have these two buttons. Now, normally we've been clicking on the top button to load the Ajax file. And if we click on it, just make sure it still works. It still works, and that's pretty fast. It doesn't have the latency that the google.com website would have from a remote access. But the question is, what happens now with this button if we click on it? And we don't see anything yet, and let's talk about why that is. So if, for example, we launch the app again, we can hit spacebar here to raise the dirty flag and hit save so that the compiler thinks it needs to start all over with the build on the project. We'll get a fresh copy of that app. What if we click this button down here? So it does the same thing. So up to this point, all buttons lead to this one on-click function, and the on-click function doesn't recognize the difference between button number 1 and button number 2. But fortunately, we do get a reference to a view object, v1, that is a handle to the button that we actually clicked. So let's take a look at what that could be used for. So we could say something like this, log.I and take the view v1 dot we'll get the something useful from it. Let's try toString first, and if we like that, we could keep that or else change it. And then also let's get the ID. So when we click on the button, we should see 4 different things. We should see a begin and an end in the log file. We should see a toString descriptor for that object, and also we should see the get ID. It should return an ID for that object. Now remember that we're using IDs, r.id.b1b2, and the expectation that I would have is that for the button, if we go back into r.java, under the IDs, we would see these things. So B1, B2, if we look at the actual raw file, B1, B2, we would see this number right here, 1 or 2. So 7F05, 0001 and 7F05, 0002. But the logcat might actually not display that number as hex. It might actually be a decimal integer value. So we'll find out. So let's go ahead and close that window. Let's hit go. Here's our log file. So if we hit the first button, here's our on-click stuff. So here's the begin end, Android widget button, and then a type for that button. But look at this number here. Here's our original unique ID for that object. So it ends in 4113. If we do it again, click on the bottom button, we have 4114. So let's say that we wanted to continue to use the on-click event, the single on-click event, to handle all the click events on this form. But we want the user to be able to click on more than one object to trigger the on-click function. So the next step then is to sort out which object triggered that event. So how do we do that? We know now that the v1.getID is an integer. It's unique across all the objects. And that would be an easy tool to use to switch the logic, like a light switch. So we could use a switch statement based on the content that we get back from that ID. So if the case is r.id.button1, then do one thing. If the case is put switch statement, and we'll just put B1 as the output here. And I'll leave this blank right now, but we're going to have to come back and exit out of that, because what happens is that as soon as we match on the first entry of a switch statement, we're actually going to fall into every other case example. But let's do that. We'll test it first, then we'll fix it. Okay, so let's stop right here. It looks okay the way it is. We'll hit go. So we have button number 1, button number 2. We have the log file. Let's empty that out. Button number 1. So notice that we see the switch statement returning positive on B1 and B2. And the second button is returning positive only on B2. So the switch statement under C in Java says that we need to actually exit the statement once we're done on the first match. Otherwise, it'll domino through all the logic below that follows it. Okay, so the keyword that we're looking for here is break. So it means that we want to break out of the switch statement. And the basic logic here is that by default, if for example we had an application that hooked on the first case statement as true, it would do something, but it would do all the code that follows unless it sees a break. So break is like a period in a sentence. Okay, so here we go. We have the buttons, we have the log file, button 1. That looks good. We're only seeing button 1. Button 2, we're only seeing button number 2, and we see these IDs, so we're correctly binding the right ID for the button to the right code. Now, the logic that we like to apply is to load AJAX on the first button and to call an AJAX function on the second button. So let's test that out. So the web view code is going to move into here. And actually that's something that we could just leave here because we're going to actually use it either direction that we go. Okay, so button number 1 loads the URL. Then button number 2 is going to call a JavaScript function. So webview1 underscore Java load the URL. And the URL that we want to load is actually not a new file, but JavaScript colon and then the name of the function inside the JavaScript inside the HTML document. So we need to make some changes to that file. So when we reference JavaScript colon, we're not actually referencing a different file. We're actually going into the existing file and we're calling a function in that file. So before we call it and before we reference an object's name, we actually need to write the code in JavaScript with the function names that we're looking for. So let's save the file that we have. It's not ready to run quite yet, but we're going to flip over into the AJAX file that we're building under the assets folder. And we're going to make some changes to the content here. So I double clicked on the file and I see the browser display for that file, which is nice if I want to only look at the output. But if I want to make changes to it, I'm going to right click on it, say open with the text editor within Eclipse, and here's the raw file. So now let's add some JavaScript. And remember that if we employ a variety of JavaScript and dynamic HTML and some XML, we can come up with some AJAX code. And that's the direction where we're headed down. So let's take a look at a function. We'll just say function my JavaScript function. And we could use the convention that we've been using before, appdev Android JavaScript function. So let's copy this to the clipboard. And that now is the name of the function. And now we need to make it do something interesting. So let's say that this was a span that had an ID. And let's call it appdev Android HTML5 span. So depending on what browser that we have, there are a number of different ways to access the ID. If we're using Microsoft Internet Explorer or if we're using the WebKit, it's a little bit different, but let's use one that works on both. So we could create a variable called appdev JavaScript span that's equal to document dot get element by ID. And we're looking for this right here. once we have it, let's change it. So we'll say something like this. Go into that span. And set it equal to something else. And we'll try it out. We have a reference here to var, which basically is a generic spelling error because we're using HTML here. So we're not going to worry about that right now. So now we can load the document. That looks good. And this hello world, we want to change it to say hello Minnesota. So the question is, we're clicking on the button. If we go to the logcat, we're not seeing anything change on the screen. If we go to the logcat, just make sure everything's coming in here. We see the switch going into B2. That's good. So the next question is how the function is working or not working properly. We're calling this function appdev Android JavaScript function. We're expecting to receive a handle to the span. We're expecting to reference the span's inner HTML and reset it to something different. And we're not yet seeing that content display on the screen. So anytime that we try to invoke JavaScript within the web view, unless we've set the permissions, we're not going to see anything happen. So this permission is not set in the same place where we also set the permissions for the internet access. Remember this under the Android manifest earlier, we set the permission to access the content out on the internet, on the public internet. So we did this uses permission, Android name, android.permission.internet. So that's not the same path that we want to go down for JavaScript. So for JavaScript, there's a little bit different path. We actually go into the code, and on the web view itself, we grant permissions from a programmer perspective. We just say wv1 for web view 1 dot get settings dot set JavaScript to true. So without this one line of code, the JavaScript functions are turned off inside of any HTML document that we look at. So let's test it out now. So there's the base file, and here's our updated version using Ajax to update the HTML5 document. And also, if we compare the notes here on the text view from Android Markup Language to the HTML side by side, the user's not going to notice the difference between HTML5 content over Android Markup Language content. They basically are on the same playing field. And the HTML document has this advantage that it can use JavaScript, which is probably the most rapid development environment that we can probably ask for. And then we can mix that with Java out here. So we can build Android applications, enterprise applications, that could do anything. And we could try to build 90% of it as HTML5 that will run on all mobile phones, platforms, Windows, BlackBerry, iPhone, Android. And then reserve 10% of the shell, the wrapper piece of that, as native code. So this is one of the approaches to building cross-platform applications, is applying a web view, applying HTML5, and also Ajax.